This video is going to cover some examples of how to use the laws of logarithms in order to expand and simplify expressions. Just as a reminder, these are the laws of logarithms that we went over in class, where if you're taking the log of a product, then you can split it apart into two separate logs connected by addition. If you have the log of a quotient, then you can split it apart into two logs separated by subtraction. And then if you're taking the log of a power, then it's possible to bring the exponent of that power to be the coefficient of the log. So here's our first example. We'll start by expanding this expression. And I'm just going to look at each law one at a time. So I'm going to start with the property that involves splitting apart a log of a quotient. Right off the bat I can see that I have a fraction, and so I'm going to go ahead and rewrite my expression so that it's no longer a fraction. Whatever is in the denominator is going to end up becoming part of a log that is being subtracted. That's what this property is saying here. So whatever's in the denominator, it gets its own log and it becomes negative, essentially. So now I can rewrite this as the natural log of the numerator minus the natural log of the denominator. The next property that I'll take a look at is the log of a product, and I can see in my first log I do have a product, and my second one I don't. X plus 1 is not a product, so that one cannot be broken down any further. But in the first one we've got a times b to the third, and so we can split that apart into two separate logs that are connected by addition. Finally, we'll look at the last property, taking the log of a power. The only one that applies to is our middle term, where we're taking the natural log of b to the third, and we're going to bring the power of 3 down in front so that it becomes a coefficient. The other two logs that I have there, natural log of a and minus the natural log of x plus 1, those aren't going to change. And that's it. That's our final result. That is as much as we can possibly expand it using these laws. Now we'll take a look at a second example where we're going to simplify an expression. And I'm going to go ahead and work with the laws in reverse order that I did on the previous problem. So I'm going to start with the property or the law that involves taking the log of a power. And I'm going to go through and look at all my terms, identify the coefficients, and those are going to become exponents. So now I have the log of x raised to the third power, the log of t raised to the second power, and the log of y squared plus 1 raised to the fourth power. So the numbers that were previously coefficients are now exponents. Next, I'll take a look at the property that involves condensing logs that are being added together. So that applies to, in this expression, the first two terms that we have. Those are connected by addition. So what we're taking the log of, x to the third and t squared, those are now going to be connected by multiplication in a single logarithm. So that will turn into the log of x to the third times t squared, and then the subtraction part doesn't change as of yet. Finally, the last property I'm going to look at is dealing with subtracting logs. We're going to put that back together into becoming a quotient. Whatever is being subtracted, that's the part that goes in the denominator. So in this case, y squared plus 1 to the fourth power, that's what's going to end up in the denominator of our final answer. And then whatever's positive is going to end up in the numerator. So now I can go ahead and write this as a single logarithm. I'm going to set up my fraction. X to the third times t squared will go in the numerator. Y squared plus 1 raised to the fourth power will go in the denominator. And that's it. We've now condensed that down to a single logarithm, so that's as far as we can take it. I hope this helps you with your homework assignment, and make sure to come to class prepared with questions to ask.